Picture a psychology lab. Back in 1969, researchers bring in this incredibly gentle, sweet-natured cat named Maynard.
Right, the classic Maynard study.
Yeah. So they have a group of 3-year-olds play with him, and the kids are totally in love. But then right in front of these toddlers, a researcher takes a realistic, terrifying mask of a fierce dog and just straps it onto poor Maynard's head.
And the reaction from the children was just absolute instantaneous panic.
Oh, complete meltdowns.
Exactly. I mean, the kids under 3 cried out in genuine terror. They were fully convinced that this sweet little cat had magically, literally transformed into a vicious hound.
Like, just because the face changed, the actual reality of the animal was entirely rewritten in their minds. It's wild.
It really is.
Well, welcome to today's deep dive. We are looking at an incredibly fascinating stack of materials today, pairing some classic case studies from a psychology instructor's manual, specifically on cognitive development in childhood, with a series of contemporary higher education news reports from earlier this year, 2026.
It's a really great combination of sources.
It is. And our mission today is to unpack the mysterious journey of how the human mind learns to interpret the world. We'll trace the path from a child's fragile, confusing early perceptions, like thinking a cat becomes a dog, all the way to the complex, abstract reasoning that we rely on as adults.
Because that journey is anything but simple.
Totally. So whether you are listening to prep for a massive project at work, or you're just, insanely curious about how your own brain is wired, this deep dive is going to reveal the hidden architecture of your intellect. So, okay, let's unpack this. Why were those toddlers so fundamentally terrified of Maynard?
Well, what's fascinating here is what that terror actually represents about the physical architecture of the brain.
Yeah.
When we talk about cognitive development, it's tempting to just think about learning to read or, memorizing multiplication
Oh,
tables.
the typical school stuff.
Exactly. But this experiment reveals that early cognitive perception is a deeply fragile structural journey. Those toddlers panicked because their brains just hadn't yet developed the neural pathways required to separate appearance from reality.
They literally couldn't process it.
No, they lacked fundamental processes, things like advanced object categorization and stable depth perception. If those foundational cognitive processes aren't fully formed, reality itself doesn't feel stable.
Wow. So to them, a mask doesn't just hide a cat. A mask deletes the cat and creates a dog out of thin air.
Yes, it's a complete overwrite of reality.
And that fragility doesn't just vanish the moment we blow out the candles on our 18th birthday either. You can actually see the long-term fallout in the higher education reports from March 2026.
Oh, absolutely. The data there is pretty striking.
It is. It shows first-year college students deeply struggling with complex problem-solving and highly abstract course structures, and academic advisors are tracing this heightened anxiety directly back to pandemic-related disruptions during their early childhood development.
Yeah, it creates a fascinating, if somewhat troubling through line. Because when early developmental milestones are interrupted, say, by a massive global shift in social and educational routines, the foundational processes just don't solidify at the typical rate.
They get delayed.
Right. So when these students, whether they're traditional teens or older non-traditional learners, are suddenly asked to navigate highly abstract university courses, well, their cognitive framework just buckles under the strain.
Think about it like a major software update at your job.
Oh, that's a great way to look at it.
Right. You log in on Monday, the user interface is completely redesigned, the buttons moved, and suddenly you don't know how to do tasks you've done for years. We still experience that panic when the appearance of something familiar suddenly changes. It proves that cognitive perception remains a delicate structure, even for us.
Which means understanding the exact milestones of intellectual growth isn't just like a niche topic for pediatricians.
No, not at all.
If you manage a team or design software or teach a class, you are actively interacting with the developmental history of the people right in front of you.
So if our cognitive foundation is that vital, we really need to know how it's built in the first place. But looking at the history of psychology, answering the how was basically a giant turf war.
Oh, it was a massive battlefield. Throughout the mid-20th century, you had these brilliant theorists proposing wildly different frameworks for how human reasoning grows. They were trying to map an invisible landscape, and they all drew completely different borders.
Let's start with the most famous heavyweight, Jean Piaget.
Yes, the classic structuralist.
He famously observed his own children to build his theories, right? He came up with those classic conservation problems that every single psychology student learns about.
The water glasses.
Yes. He'd take identical amounts of water, and right in front of a young child, he'd pour the water into two glasses of completely different shapes. One is a tall, skinny cylinder, and the other is this short, wide bowl. And the young kids were totally fooled. They confidently pointed to the tall glass and said it had more water.
To understand why they do that, you have to look at how Piaget defined cognitive structures. He called this a structuralist theory, arguing that cognitive development is actually discontinuous.
Meaning it happens in chunks.
Basically, he believed children progress through 4 distinct invariant stages. So from birth to age 2, infants are in the sensorimotor stage, learning purely through touch and movement.
Just grabbing everything.
Right. But the kids failing the water test, they're in what he called the pre-operational stage. Their brains literally cannot hold 2 variables, height and width, in their working memory at the same exact time.
So they just focus on one thing.
Exactly. They center entirely on the visual height. Piaget believed they wouldn't grasp the real physics until they leveled up to the concrete operation stage, and then finally the formal operation stage around age 12, where abstract logic clicks into place.
So it's a very rigid model, step 1, step 2, step 3.
Like a staircase, yes.
But then another camp emerges and basically says, no, the brain isn't a staircase, it's a machine. The information processing theories totally reject Piaget's rigid stages.
They really do. They model the human mind like a digital computer processing data sequentially.
So how do they explain the water glass test?
Well, from this perspective, the reason a child fails the test isn't because they are trapped in some mystical pre-operational stage. It's simply a hardware limitation.
Like they don't have enough RAM.
Precisely. Their working memory capacity is just too small, and their processing speed is too slow. As the physical brain matures literally, as the myelin sheaths around neurons thicken, their mental RAM gets upgraded, they can process more data simultaneously.
Okay, so we have stairs and we have computers. But then, turning from an entirely different angle, we get Lev Vygotsky and the sociocultural theories. And he essentially looks at Piaget and the computer model and says, you guys are completely ignoring the most important variable, which is other people.
Yes. Vygotsky argued passionately that social interaction and cultural tools are the actual architects of our internal mental structures.
We don't just grow in a vacuum.
Exactly.
Yeah.
You don't just upgrade your brain's hardware all by yourself in a dark room. Development is deeply embedded within our cultural contexts and even the specific language we use with our caregivers. He has this beautiful defining quote in the literature: "Through others, we become ourselves."
I really love that. Through others, we become ourselves. And it's highly practical today, too.
Absolutely.
Like the June 2026 university study in our stack looked at non-traditional online students. And researchers found that these adult learners learned significantly more effectively when their courses incorporated Vygotsky's social learning principles.
Right, because when universities finally abandoned isolated lecture videos and instead built structured, collaborative digital forums into the coursework, first and second year graduation rates improved dramatically.
It's huge.
The students needed that social scaffolding to process the difficult material. They needed each other.
But I have to push back here for a second. When you look at the history of psychology, it feels like these theorists were just obsessed with proving each other wrong. Why does it have to be a battlefield? Like, can a developing brain act like a sequential computer and a social sponge at the exact same time?
You know, psychologists today would absolutely agree with you. The field spent decades locked in this theoretical tribalism before realizing that isolated models completely fail to capture human complexity.
It's never just one thing.
No, you simply cannot separate the mechanical processing of the brain from the social environment it operates in, which actually brings us to the ultimate intertwined system, the great debate between biological nature and environmental nurture.
Oh, here's where it gets really interesting. Our stack highlights an observational study from 1995 by Judith Langlois, and she examined the emotional ties between mothers and their infants.
Yeah, and it's a study that makes people a bit uncomfortable, but the scientific mechanism it reveals is crucial.
It is uncomfortable. The data showed that parents naturally provided more affectionate, engaged care to easygoing, visually appealing babies than they did to babies who were fussy or had, difficult temperaments.
Right, and the scientific takeaway here isn't just a critique of parenting. It demonstrates a concept called evocative genotype-environment correlation.
That's a mouthful.
It is, but it basically proves human development cannot be neatly split into separate buckets of biology and environment. A child's genetic traits, so their innate temperament, their baseline neurochemistry, which is their nature, actively alter the social environment they experience daily, which is their nurture.
So the baby's biology physically changes the way the mother nurtures them?
Exactly.
Like a smiling baby triggers a dopamine release in the parent, which prompts more affection, which in turn wires the baby's brain for even more emotional security.
Yes, it's a constant compounding feedback loop. Genes provide the foundational blueprint for the brain's structure, but your everyday experiences dictate how those neural connections mature and prune themselves.
Like it's all connected.
A child's innate personality evokes specific reactions from teachers, peers, parents. Those reactions alter the environment, which then guides the child's future intellectual trajectory. Donald Hebb captured this perfectly. He said, "Nature grants the canvas, but nurture paints the masterpiece of the human mind."
That dynamic is still playing out for adults right now in 2026. Look at the April 2026 report on urban community colleges. They tracked non-traditional students balancing full-time jobs with their studies.
A very stressed demographic.
Very. And these students showed massive cognitive adaptability, but only when the college provided them with highly supportive peer networks and modernized study labs. By optimizing the environmental nurture, the college allowed these adults to fully unlock their biological potential.
The environment essentially dictated the maximum altitude they could reach. It's the Langlois infant study playing out at age 30.
Exactly. I want you to think about your own life for a second. How have your innate traits, your specific quirks, the things you're naturally good or bad at, changed the way your managers, your teachers, or your friends treat you? And how did that specific treatment shape the person you are today?
It's a wild loop to consider.
It really is.
And once you recognize that nature and nurture are caught in this infinite loop, well, the next logical question researchers had to ask was, what does the timeline of that growth actually look like?
Right.
If intelligence is a canvas being painted over a lifetime, is the paint applied in sudden splashes, or is it a slow, meticulous burn?
Which brings us right back to that historical debate of discontinuous versus continuous growth. Piaget argued for discontinuous growth. He thought intellectual maturity happened in abrupt qualitative shifts. You're on one level of reasoning, and then suddenly, boom, you step up to a completely different mode of thought.
Like climbing a staircase.
Right, the staircase model. But the information processing theorists argued for continuous growth. They saw development as a gradual, quantitative expansion. It's just a slow, steady accumulation of memory capacity and processing speed.
So instead of a staircase, it's like walking up a smooth, steady slope.
Exactly. But then, in 1997, Robert Siegler enters the conversation and essentially proves both the staircase and the slope analogies are totally flawed.
Yeah, Siegler really changed the game.
He created the overlapping waves model. He tracked exactly how young kids learn to solve math equations over time. So let's say a child is trying to solve 3 plus 5. On Monday, they might count on their fingers 1, 2, 3, and then 4, 5, 6, 7, 8. Very basic.
Super common strategy.
Right. On Tuesday, they might just retrieve the answer from memory and shout 8 because it just clicked.
But on Wednesday, faced with the exact same problem, they might revert right back to counting on their fingers. Siegler proved that kids don't just jump from one logical stage to the next and stay there permanently.
It isn't a fluid escalator ride.
No, instead, the brain is a fluid sea of changing strategies. At any given moment, a single child is using multiple ways of thinking simultaneously. They're constantly weighing the speed of memory retrieval against the guaranteed accuracy of counting on their fingers.
So the strategies overlap and crest and fall like waves. Some days the advanced strategy wins, and other days the brain relies on an older, safer method.
And we connect this to the bigger picture, it reminds us that intellectual maturity is beautifully complex and non-linear. Erik Erikson summed this up beautifully. Continuity and change are the twin tracks upon which the train of human development runs.
Those twin tracks are heavily relevant for adult learners today. Higher education journals from January 2026 explored how first-year college students adapt to academic expectations. Non-traditional adult learners often feel totally overwhelmed because the academic shifts feel incredibly abrupt to them.
It feels like hitting a massive discontinuous wall.
Exactly. While traditional students coming straight from high school sometimes show a more continuous, gradual adjustment period. Tracking this specific developmental pacing is actually helping colleges redesign their onboarding programs to match how adult brains genuinely process change.
Vital work.
So what does this all mean? We always think of learning as either climbing a rigid staircase or riding a smooth escalator. But Siegler is saying it's actually like surfing. We're constantly riding multiple overlapping waves of thought at the exact same time. Some days you catch the big advanced wave, and other days you wipe out and go back to the kiddie pool, and that's completely normal.
It really is. And having established that cognitive development is this complex, overlapping sea of strategies,
Yeah.
the conversation naturally shifts to practical application. Like, how do we harness these complex ways to actually help people who are falling behind?
Because this research isn't just academic trivia, it's actively pulling kids out of systemic academic failure. There's a landmark 2008 intervention by Robert Siegler and Geetha Ramani. They went into classrooms of lower-income preschoolers who were significantly falling behind wealthier peers in math. And instead of drilling them with flashcards or making them stare at a chalkboard, they had them play a simple numerical board game.
It was essentially the classic game Chutes and Ladders. The mechanics are simple, but what it does to the brain is actually profound.
Just by rolling a spinner and physically moving a token across numbered squares, the kids were building an understanding of numerical magnitudes, this spatial, conceptual understanding of the relative size of numbers.
Which is huge for math.
Right. And wealthier kids often get this spatial temporal mapping naturally because they play board games at home. Disadvantaged kids often don't have that same exposure.
The physical act of moving the token builds a linear neural pathway in the brain. It physically maps the numbers, and the results of the intervention were staggering. Just a few hours of this playful, targeted game completely erased the socioeconomic math achievement gaps between these kids and their wealthier peers.
A few hours of a board game leveled the entire intellectual playing field. That is amazing.
It is. And this raises an important question about how our modern institutions operate. When we actually understand the specific mechanisms of cognitive development, we can completely transform teaching.
We can work with the brain instead of against it.
Exactly. Another great example is phonemic awareness, the ability to isolate individual sounds in spoken words. Once researchers realized this was the foundational wave for reading, educators redesigned early literacy curriculums to align with how the brain actually decodes sound. By applying these scientific findings, we proactively rebuild the foundations that poverty or disrupted environments might have fractured.
We're finally moving away from rote memorization. Just staring at a textbook doesn't match the overlapping waves of the brain.
The February 2026 feature article in our stack confirms this is actively happening in higher education too. Regional colleges completely redesigned their remedial mathematics classes. They took first and second year students who were failing traditional lectures, and they introduced interactive, gamified learning tools.
They gave 19-year-olds the adult version of Chutes and Ladders.
In a way, yes. Traditional remedial math often triggers anxiety in the amygdala, which basically shuts down the prefrontal cortex, the logic center of the brain.
Oh, so you literally can't think.
Right. Gamification bypasses that fear response. It allows the adult brain to engage its natural problem-solving strategies without the paralyzing fear of failure. The failure rates in these gamified courses plummeted. It confirms that when instruction aligns with the natural capabilities of the developing brain, you get extraordinary results. As the philosopher Plutarch famously said, the mind is not a vessel to be filled, but a fire to be kindled.
Imagine if your workplace training or the hardest class you ever took was redesigned to match the natural overlapping waves of your brain. Instead of a boring manual that expects you to process information like a computer, what if it was an interactive experience that built on your intuitive reasoning? How much more potential could you unlock?
It completely reframes what it means to be bad at a subject. You aren't bad at it. Your brain just hasn't been provided the right environmental scaffolding to build the required neural pathway yet.
Let's look back at the journey we've taken today. We started with Maynard the cat and the fragile, sometimes terrifying beginnings of how a young mind perceives reality. We walked through the great historical battles of psychology, Piaget's rigid stares versus the computer models versus Vygotsky's cultural scaffolding. We untangled the deeply connected feedback loop of our biological nature and our social nurture.
We covered a lot of ground.
We really did. We discovered that learning isn't a straight line, but an overlapping sea of strategies. And finally, we saw how mapping that sea is literally saving academic careers in 2026 through gamified, brain-aligned education.
It's a remarkable synthesis of how the mind grows. And, it leaves me with one final thought, particularly building on Siegler's overlapping waves model and those 2026 adult learner studies. Well, if childhood cognitive development isn't a set of rigid stares, but rather a fluid sea of changing strategies, what does that mean for our adult identities? We often label ourselves as not a math person or a slow learner, assuming our cognitive development just froze at age 18. But if your brain is inherently built to surf overlapping waves of problem solving, maybe the fixed adult intelligence you think you have is just a temporary wave, and you are completely capable of catching a new one tomorrow.
I love that. You're never frozen on one step. Well, thank you for joining us on this deep dive. Keep questioning the world around you, keep looking for those new waves, and remember that even if the cat puts on a dog mask, the world is still yours to figure out. Catch you next time.